Hello to week 1 of Geography 212, Introduction to Meteorology. What we're going to talk about today is what's the difference between weather and climate. First off, weather. As you can see from number 1 here, the state of the atmosphere at a specific time and place. And one of thousands of examples of giving this would be something called the Aviation Routine Weather Report, or what we call METAR. So if you look down closely here, what we see is KRPC is going to be the code for Prescott's Love Field. The next few numbers are going to give you things like the day of the month, the time in Zulu time. You're going to get the wind at 220 degrees. It's 15 miles per hour, gusting to 25 knots, so on and so forth. That's just one of many ways that we can give the state of the atmosphere at a specific place and time. And number 2 then, meteorology is the science that studies the weather. Now climate. Climate's also concerned with a specific location, but it's concerned about weather compiled over a long period of time. Now, international convention does dictate that we take average weather data over a 30-year period, and we begin with the first year of the decade. For example, our current climate cycle is from 1981 to 2010. The next one will be 1991 to 2020. So in other words, when you hear that the average temperature or normal temperature for this date and this time of year, that's the 30-year average, all right? Now, we're going to be looking at a lot of surface analysis maps throughout this course, and I just wanted to give you an introduction, and this is expanded upon in Chapter 1 in your textbook. But first of all, if you take a look at this real basic surface analysis over in the left corner here, first of all, take a look at the L's. The L's are low pressure systems, which we call cyclones, that have cyclonic circulation around them. Cyclonic circulation is counterclockwise wind movement. Now, low pressure systems or cyclones also feature wind that ascends in the middle. So air is rising in the center of these low pressure systems. So counterclockwise and inward is the type of circulation these low pressure systems have. High pressure systems we also call anticyclones. Anticyclones are going to have air that descends from the atmosphere, from high in the atmosphere down toward the surface, and the air circulates in a clockwise manner. These systems typically produce fair weather, whereas your low pressure systems or cyclones will produce cloudy and usually some form of precipitation. So low pressure systems, clouds and precipitation. High pressure systems, generally fair weather with light winds. Now, I'm going to skip down to number 4, air masses. Air masses are these very large volumes of air that have relatively uniform temperatures and moisture content. They obtain their temperature and moisture content from the surface that they were in contact with. So, in other words, if we take a look at an air mass, the first one I've listed there, MP or maritime polar, that's going to be an air mass that's formed up over, say, the North Pacific Ocean or the North Atlantic Ocean. So, moist and cold characteristics. Now, an air mass that's formed up, say, over the Canadian Arctic or subarctic, its characteristics are going to be dry and cold. We call that CP or continental polar air mass. Now, if we have an air mass that's formed up, say, over the Gulf of Mexico, South Atlantic, or the Southern Pacific, that's going to be moist and warm, and we call that maritime tropical air. Now, air that forms up over a very hot, dry location, like the U.S. Southwest, would be dry and warm. We call that continental tropical air. Now, these air masses of different temperatures and moisture, when they come in contact with an air mass of different temperature and or moisture, they don't mix. Air masses don't mix. That's why boundaries form between them. That's what fronts are. So fronts are boundaries between air masses of different temperature and or moisture. And you can see the symbols that we use for cold fronts, warm fronts, and stationary fronts there in the lower left. But again, we'll be getting into a lot more of this in detail later on during the course. Here's a couple of diagrams featuring high pressure and low pressure systems so you can better visualize the type of circulation around them. So if we take a high pressure system here, you can see that we've got this clockwise circulation, but air is also moving away from the center of a high pressure system. The highest pressure, of course, is going to be right here in the center of the hive. Moving over to a low pressure system, you can see the wind is counterclockwise but also moving in toward the center of the low. And at the center of the low is where we're going to have the lowest pressure for this system. This is a cross-sectional look at a warm front and a cold front. And as I'd mentioned before, these fronts are boundaries between different air masses. Now, these boundaries generally produce what we call lift in meteorology. Lift is simply where we get air to rise. All right. Now, when air rises, it's going to cool slowly, and if it does reach what we call its saturation point or dew point, the water vapor, which is H2O gas and is invisible to the human eye, will condense to liquid water, or H2OL, which is visible to the human eye. So something very important here: clouds are not water vapor. Clouds are not gas. Clouds are liquid and or ice crystals. You know, some clouds can be all liquid, some clouds can be all ice crystals, but some clouds can be combinations of them. So clouds are liquid or solid H2O. Now, the other thing around fronts here, let's take a look at this top one here, where we've got this cold air advancing. Sorry, this is a warm front. We've got the warm air advancing into the cold air. What happens is this warm air encounters the cold air. The cold air is denser and heavier. Therefore, the warm air is forced to lift. And in this case, it's lifting, it's cooling, condensing, and forming cloud here. Down here's the cold front. We have cold air advancing into warm air. Remember, the cold air is denser and heavier, so as it advances into this warm air, it's forced to lift, and in this case showing condensation and some precipitation forming. The state of the atmosphere, there's a section in Chapter 1 regarding this. I'm not going to go into the details here. You can take a look at that, because again, we'll be spending more time with this when we take a look at something called station models. Anyhow, the state of the atmosphere is going to describe current or past conditions at a certain location. And these parameters include things like air temperature, and it can be the current temperature, the maximum for the day, or the minimum for the day. Dew point, the temperature at which your air is going to reach 100% relative humidity. The relative humidity, or the amount of moisture, water vapor in the air. Precipitation amount, current air pressure, the wind direction and wind speed, sky cover, and weather. Now, when we talk about weather, we're talking here about what type of precipitation, or are there other atmospheric conditions that limit visibility, things like dust in the air, smoke in the air, that kind of thing. The Chapter 1 also introduces the concept of satellite imagery. Satellite imagery has been it's given us an amazing advancement in meteorology, particularly when we get into weather forecasting. Now, the satellite imagery we'll most be looking at in this course are from geostationary operational environmental satellites. We call them GOES. We like the acronym GOES better. Now, they're going to orbit Earth above various locations, and they're going to be at a precise orbit where they're going to stay directly over what we call their sub-satellite point. And they'll be taking images, continual images of Earth's surface and any of the cloud cover that's occurring there. Okay, and these GOES satellites are going to give us different types of images. The three that we will be looking at throughout the course are visible light images, infrared light images, and water vapor or H2O gas images. Now, if you look on the left, that is a visible GOES image. Now, these are satellite images that utilize only visible images, daytime sunlight. So in other words, if we take a look at part of the United States here, in this case it's going to be the west, you're not seeing any cloud. That's because it's still dark there. Okay, so the sun rises from the east. So the visible light from the sun is giving us images on the cloud, from about Missouri and Iowa east, as you can see. So visible images are only useful during daytime, which limits their usefulness. But if you look to the right, we see an infrared image, and this is taken at the same time as the one on the left, the visible image. So you can see that this one, even though it's dark west of, say, Missouri and Iowa, it's still showing up the clouds that are occurring in the northwestern part of the United States. Now, the other thing about infrared images is it's calibrated to show that our colder clouds, which really mean their tops are higher, as being brighter. So if you take a look down here in these clouds over Florida, you can see they're quite bright, as are these clouds on the eastern part of North Carolina. They're also quite bright. And that's simply indicating they're very high, therefore they're very thick. So you probably got some weather happening there in the form of showers or thunderstorms. And finally, the last thing we're going to take a look at is, or just introduce here, is weather radar. It's extremely important, another very valuable tool that we use in weather forecasting. What weather radar does, some people, it's Doppler radar. It picks up precipitation. In other words, rain, snow, hail, snow pellets, goes on, right? There's many different types of precipitation. And in this case, it's going to color code it in terms of the intensity of the precipitation. So if you look over here to the left, you'll see that that's the intensity. So if you're in purple, such as over here in southern Wisconsin, northern Illinois, it's very light precipitation, low intensity. But then if you take a look at the red over Massachusetts, off North Carolina and down in Florida, you'll note this is red. This is a much more intense precipitation. And again, we'll be taking a look at these types of maps and using them a lot more in detail further along in the course. All right, so that's all for now.